Hi, everyone. I'm going to teach you how to factor today. And we're going to actually start off with just some basic factoring. And even before that, just what is factoring? So let's start with something that you've done before. If I said list the factors of 15, you would list all the numbers that multiply with to 15. So 1 and 15, 3 and 5, and that's it. So factoring is us taking a number or a term and breaking it down into smaller pieces that multiply to get back to that same value. We can do that with full-on expressions. Now, before we jump into the full-on process, just kind of like the first step into factoring is to find what's called a common factor. And really what we want to do here is find the greatest common factor. The greatest common factor is what term divides every single thing in an expression that we're looking for. So the one that a lot of students usually get without any issue are the numbers themselves. So what divides 24, 36, and 32? We want to find the biggest number possible here. So I'm going to try maybe 4. So it's 24 divided by 4, yes. 36 divided by 4, yes. 32 divided by 4, yes as well. So they can all get divided by 4. Now the next thing that we want to divide out is any variable that they all share. Now I'm looking at all these terms and they all have at least one p. So I'm going to also divide out that p. Now, since we're wanting to write a similar expression to where we started, this 4p doesn't just go away. So what we're going to do is we're going to write down the 4p and we're going to multiply it by whatever the result is from taking each term and dividing it by 4p. So negative 24 divided by 4 is negative 6. P cubed divided by p is p squared. Moving on to our second term, 36 divided by 4 is 9. P squared divided by p is p. And last term, 32 divided by 4 is 8. And p divided by p is 1. So those terms actually cancel out. And so this expression here, if we were to redistribute or multiply, we end up getting the exact same thing for where we started. So that's a way that you can check it, right? If I do distribute this 4p to all those terms, so I get back to where I started. If so, you've at least factored out something. That doesn't necessarily guarantee you factored out the greatest common term, but you've at least done something. Now I want to come back and talk about what factoring is in general, right? I started off by dividing, and that's actually a way for us to factor numbers, right? If I take 15 and divide it by 5, I get 3, which allows me to say that 5 times 3 is the factors, right? That's really what we're doing here. We're looking at what we're trying to divide, or what our full-on expression, and we're asking ourselves, what can we divide into all those terms? That's what factoring is. All right, well, why don't you hit pause and find the greatest common factor for 3, and then I'll have that factored expression for you after you hit on pause. All right, so I noticed that all of these terms can get divided by 10. So that was the number for the greatest common factor. And then they all have definitely x's, but we want to take out the most amount of x's possible. And all of these terms have at least an x cubed, right? There's an x cubed and an x to the 5th, and an x to the 7th, and an x to the 8th. So we want to take out as many x's as possible. So 10x cubed is our greatest common factor there. All right, so factoring out greatest common factors, that's usually going to be your first step. Do I see any common factors? And then we'll jump into the full-on factoring process, which we're going to get to in just a moment, because to kind of set up how we're going to factor, I want to actually do the opposite. So what we see here, this is what we would consider a factored quadratic. And that's the case with 5, 6, 7, and 8. Those are all factored. How do I know that? Because if I were to multiply these, I would get back to a similar equation that represents a quadratic. So really what we're given here is 3 times 5. And we're asking or trying to figure out what is 3 times 5? That would be 15. So with this expression, we need to figure out how do we multiply these two terms to get to our standard form of a quadratic. Well, we're going to use what's called the area model. The area model sets up our terms so that we make sure everything gets multiplied correctly. So really it's just a box with 4 different squares. And what I'm going to do is I'm going to take each factored term, or each binomial meaning 1, 2 terms, and I'm going to list it along the top, 3m minus 5. It could also have gone down the side. The placement here does not matter. And 4m plus 2. One thing that is really helpful here, and something that we should always do, is write down the signs. right? 3m and negative 5. I want that negative to be clear that it's on the 5. 4m and positive 2. I want that 2 to be very clear that it's positive. I don't want to have to think back to that because this is usually the most mistakes happen with signs. So what we're going to use this model for is to find the area of each square. Each area is its height times its width. So if I take this height of 4m times its width of 3m, then it's going to give me the area of this smaller square here. So 4 times 3 is 12, and I multiply m times m, which is m squared. Same thing for this box over here. This height is 4m times its width of negative 5, gives us negative 20m. Down here at the bottom, 2 times 3 is 6m, and 2 times negative 5 is negative 10. So the last part of this is piecing all these terms together. We have like terms between the negative 20m and the 6m, so I can add those together. So this quadratic in standard form is 12m squared. Negative 20 plus 6 is negative 14m and minus 10. And this quadratic expression is equivalent to the one for where we started. And the area model allows us to check that. Yeah, I can go back and make sure that each of these boxes is correct. 3 times 4, 12, n times m squared, et cetera, and combining them all together. So the area model is extremely helpful. Eventually, we'll move away from it. We'll move into a more formal process called FOIL. Some of you might know what FOIL is. It's first, outer, inner, last, which just means you take the first term, multiply it by the other first term. The outer terms, the inner terms, and the last terms. Okay, we really did just FOIL, but the box is just like a tool to organize all our terms together. All right, once again, I'm gonna have you hit pause and try number 7, where you're gonna set up your area model and multiply it out to get the quadratic in standard form. All right, well, after multiplying these terms, you should have a 16v squared, a negative 16v, a 24v, and a negative 24. And after combining the like terms, so the 24v and negative 16v, that gives you 8v. So your equation in standard form is 16v squared plus 8v minus 24. And I just want to remind us that this expression that we started with is the exact same as where we ended here. We need to make that connection, and we can write quadratic equations in multiple forms. All right, so now to the actual factoring process. So in this case, we're starting with this equation in standard form, and we want to get it into this factored form. And we're going to use this area model here. Now, one thing that we need to figure out is, if you look at our area model, we have 1, 2, 3, 4 terms. But for this quadratic, we really only have 3. So the 4th term is going to come from us splitting up this negative 10b. And we have to do that in a very specific way. That specific way comes from us figuring out what number adds to b and multiplies to a times c. Well, what am I referring to with a, b, and c here? Remember, the standard form of a quadratic is ax squared plus bx plus c. So a is the number in front of the x squared, b is a number in front of the x, and c is the constant term without any variables on it. So in our case here, the numbers that add to b, where b is negative 10, and multiply to a times c is 1 times 25, which is 25. So we're going to have to do some searching here. What numbers multiply to 25 and add to negative 10? If we have trouble finding them, we can make a factored tree. A factored tree is just like what I did up here, where I take the number and I list out all its factors. So what numbers multiply to 25? 1 and 25, 2 and nothing, 3 and nothing, 4 and nothing, 5 and 5, and I think that's it. So once I have these terms here, I'm like, all right, which of these terms can I add together to get to negative 10? Well, right now, none of them. But if I make these 5s negative, then they still multiply to 25, and now they add to negative 10. So these two numbers are both negative 5. So what these numbers represent, they represent us taking the b squared, or the negative 10b, and breaking them off into two different terms, in this case, negative 5b and negative 5b, which makes sense, right? Because we had to combine those two terms in our area model when multiplying them out to get that middle term. So this work is necessary, and this is where most of your work is going to happen. Once we have all 4 of these terms, we can make our box. Inside the box, we have 1, 2, 3, 4 terms. The placement of 2 of them are really important. The b squared being in the top left and the 25 being in the bottom right. The placement of the other 2 terms do not matter. I can put negative 5b in either place. In this case, it really doesn't matter because they're all the same. So now our task is to figure out what times what gets us the area of each individual box. Well, the b squared is easy, right? The only way that I can get b squared is multiplying b times b. Then I've got to figure out b times what is negative 5b. That'd be negative 5. And we get the same thing down here because that's another negative 5b. And your check to make sure that you did this right is if these 2 numbers at the end of at the bottom of the box and the right end of the box multiply to get this bottom right square of positive 25. And negative 5 times negative 5 is 25. So our complete factored form is b minus 5 times b minus 5. And again, this is the same expression or represents the same values as our equation in standard form. And there we go. That is our first factoring so far this semester. Okay, we're going to do a little bit more here, and I'm going to actually have you start with, 11 can be a little tricky, so why don't you hit pause and do number 12. When you hit unpause, I'll have your solution for number 12. We'll do one more, and that'll conclude this video. All right, well, here's your complete factored quadratic. N squared minus 9m plus 20 factors to n minus 5 times n minus 4. Remember, we first need to figure out what numbers add to b, where b is negative 9, and multiply to a times c, where a is 1, and c is 20. So 1 times 20 is 20. Those 2 numbers are negative 5 and negative 4. And those 2 terms are how we split up the negative 9n. Once we split that up, we have 1, 2, 3, 4 terms, which allows us to start to think about what do the outsides need to be to multiply to get all of the insides of our equation. Okay, I'm going to do one more with you all, and we're going to do one that's a little more complicated, where we got to piece together just about everything we've talked about in this video, starting with greatest common factors. So typically, if we notice that we do not have, or we have an a value, so meaning the number in front of the x squared, other than 1, we want to see, can we divide all of these numbers by some value and take out that greatest common factor, because it makes the rest of our factoring so much easier. So what I'm going to do is I'm going to check to see, is there a number that divides 684 and 240? Well, I know for sure 2 is going to do that. I'm going to see the 6 divided. So I'm going to go 84 divided by 6 is 14. 240 divided by 6 is 40. So these are all divisible by 6. I'm going to factor out that 6, which leaves me with x squared plus 14x plus 40. And now this factor is so much easier. I can factor this almost the exact same way as how we factored 12 up here. The only difference is my numbers are going to be a little bit different because we have a different b value and a different c value. This 6 does not go away. This 6 you're going to multiply into whatever your factors are, which I'm going to tell you right now, your factors here would be x plus 10 and x plus 4. So this would be your complete factored equation here. I know I skipped the area model. You should not. You should draw it out. But that's an example of where a GCF can make our lives a heck of a lot easier. Now, I know I said I was going to do just one more, but we're going to actually come back and do one more on top of that, because that one was just a GCF on top of the factoring we've already done. Let's look at 19 here. 19, if I look for greatest common factor of 2, that doesn't work, right? 5 is not divisible by 2, and neither is 63. So we need to get straight into our factoring process. And the first thing to do is to figure out how are we going to split up the negative 5a? Well, we got to find the 2 numbers that add to b, which is negative 5, and multiply to a times c. So important that we remember a times c. A times c is 2 times negative 63. I'm going to need a calculator for that one. 2 times negative 63 is negative 126. So with these values, I don't exactly know. Yeah, I don't have the answers to what adds to negative 5 and multiplies to negative 126 already ready to go. I need to find those. So one thing that I can do, yes, we can make the factoring tree. There's going to be a lot of factors of 126. I can also grab this calculator and start taking guesses. Now, how do I take guesses? I start with 126 and I divide it by a guess. So we'll start with just 2 and 63. I ask myself, can I get those numbers to add to -5 by making one of them negative or both negative? And the answer is no, right? We're no way in heck are we going to get those to add to -5. So I just keep going until I find 2 whole numbers that I can get to -5. So 3 does not work. I'm just going to go down the line. What about 4? Yeah, it's a decimal, so we already know that won't work. 5 won't work because it's not divisible by 5. Let's try 6. 6 and 21, we're getting closer, right? If I make that 6 negative, then they add to -15. So I know I'm heading in the right direction. 7 and 18, those could add to 11 if I make the 7 negative. So we're still getting closer. 8, no, maybe 9. 9 and 14, are those 5 apart? They sure are. And if I make the 14 negative, now they'll add to -5. So our 2 numbers here are 14 and 9, where the 14 needs to be negative, so they add to a -5. If you make the 9 negative, yes, they'll still multiply to -126, but now they don't add to -5. So this factors to 2a squared minus 14a plus 9a minus 63. Now we can get into our box, where 2a squared has to go on the top left, -63 has to go on the bottom right, -14a, it doesn't matter if I put it in the top right square or the bottom left, and 9a in the bottom left. So now, since our a value is not 1, we have to be a little more thoughtful here in terms of what we put in these first 2 squares. You should not move on to figure out what needs to go in our bottom left square, or the top right part of our box, before figuring out what these 2 terms need to be. Well, I know for sure that a times a will give us that a squared. But one of these numbers needs a 2, right? 2a times a is 2a squared. And we need to think about, where does that 2 need to go to multiply to get a different term in this box? If I put it up top here, there is not a number that I can multiply 2a by to get 9a. So this 2 needs to go on the side that I can multiply with to get 14a. So 2a times -7 gets me that -14a. That's why the 2 needed to go there. So 2a times -7 is -14a. And our last term here, a times +9 is 9a. And remember, your check is 9 times -7, -63. It sure is. So this is 2a plus 9 times a minus 7. There's our complete factorization. All right, well, I've gone over everything you need to factor. Your task is to now finish the rest of this assignment and turn it in once it's all done. Thanks for watching. Have a great rest of your day.